Welcome to episode 13 of our AI Audit Prep series, our deep dive into managing the risks of artificial intelligence once it is actually up and running. In this session, we will cover how to continuously monitor these systems, measure their performance, and ensure they respect data privacy rules. Let us talk about why this matters for your daily career. As an auditor or technology professional, you will rarely deal with an intelligent system that is perfectly static. Knowing how to establish guardrails and early warning systems allows you to confidently advise your organization on whether a software tool is safe to deploy for critical business operations or if a third-party vendor is putting your company data at risk. Let us start with the big picture of risk monitoring and continuous improvement. Think of artificial intelligence not as a standard calculator that gives the exact same answer every time, but more like a living garden. You cannot just plant seeds and walk away. You have to constantly weed, water, and adapt to changing weather conditions. In the corporate world, this means we must actively look for new vulnerabilities and fix errors as the technology rapidly evolves. To keep this digital garden healthy, organizations must pull information from 4 specific sources. First, we look at risk mitigation efforts. This simply means checking if our planned security fixes are happening on agreed-upon timelines and adjusting those remediation plans if new threats or opportunities pop up. Second, we track performance indicators. If an application starts giving bad answers or frustrating the workforce, we have to evaluate if it needs to be retired or replaced. Third, we keep a very close eye on third parties. If a vendor supplying your technology fails to meet their contractual security or functionality promises, you need to swap them out immediately. Finally, we look at incident resolution. When things inevitably go wrong, we take those hard-learned lessons and feed them back into our oversight process so we do not make the same mistake twice. All of this ongoing continuous improvement work should be documented and tracked in a central risk register, which is essentially a master organizational ledger of everything that could go wrong and what we are doing to prevent it. Now we must determine how to actually measure these abstract concepts. This is where we use key risk indicators, or KRIs, and key performance indicators, or KPIs. A performance indicator tells you if you are hitting your business goals, while a risk indicator acts like a smoke detector, providing an early warning before a fire ever starts. When these risk indicators cross a certain predefined boundary, known as a threshold, an automated alert is sent out to a human overseer. The way we set these alarms depends heavily on whether we bought the software off the shelf or built it ourselves. Let us say you purchase an automated tool to scan incoming vendor invoices. Because it is a purchased product, you would tie your risk alarms to standard business outcomes. Your performance indicator might be processing 95% of invoices in under 1 minute. Your key risk indicator might be an alert if the tool starts flagging more than 10% of legitimate invoices as fraudulent, an error rate which would bring your accounting department to a grinding halt. However, if your own engineers build a custom application from scratch, setting these alarms gets much more complicated. You cannot just look at the final business outcome. You need a cross-functional team of risk managers, internal auditors, and statisticians to analyze the underlying mathematical behavior of the program. To help structure these complex internal alarms for internally developed systems, experts often rely on specific frameworks, such as the Key Artificial Intelligence Risk Indicators framework. A major piece of this relies on 4 pillars, known by the acronym SAFE. Let us break down what those 4 letters mean. The S stands for sustainability. This means the program is robust and stays stable even if it encounters strange data anomalies or deliberate cyber attacks. Imagine building a suspension bridge. It needs to be sustainable enough to hold its shape during a massive hurricane, not just on a sunny afternoon. The A is for accuracy. This measures how often the machine's statistical predictions match actual observed reality. If our bridge sensors predict a stress fracture, we want to make sure there is actually a physical crack when the human inspectors go to look. The F stands for fairness. This requires the technology to treat all diverse populations and demographic groups equally. Returning to our bridge analogy, a fair automated toll system would accurately read license plates for both expensive sports cars and old rusted pickup trucks without any performance bias. Finally, the E is explainability. This ensures that the key stakeholders can actually understand how the computer is making its decisions. If the bridge suddenly and automatically closes its gates, the engineers need to know exactly what lines of logic caused that action. Setting these specific metrics will always depend on how the program was constructed. For example, it depends on whether it is a white box where you can see the internal code, or a black box where the inner workings are hidden from the user, as well as the specific mathematical methods like regression or classification that the engineers utilized. Let us shift gears and look at our final topic for today, which is how this technology impacts data governance and privacy programs. Machines can read and process information infinitely faster than a human being. This incredible speed is a double-edged sword. Without strict supervision, a hungry algorithm might accidentally ingest highly confidential employee medical records or personal data, creating a massive regulatory privacy violation. But we can also use that same processing speed to our advantage to actually improve our governance programs. Think of an artificial intelligence tool as a highly caffeinated librarian. First, it can handle automated data discovery and classification. The librarian can run through 1 million unorganized books and instantly label which ones are public fiction and which ones are locked historical archives. Second, it provides data quality management. It can spot anomalies or typos in the massive library catalogue and make initial corrections instantly. Third, it assists with policy enforcement and compliance monitoring. The librarian acts as an always awake security guard, watching who accesses the restricted section and sounding an alarm if someone breaks the rules. However, there is a crucial catch here that you must remember for your exams and your career. Even if you are using an algorithm specifically to help manage your privacy programs, that algorithm itself must be audited and governed just like any other application. You have to ensure the data you feed into it is safe, meaning the watcher must also be watched. Let us quickly recap our journey today. We learned that intelligent systems require constant supervision and continuous improvement drawn from risk mitigation efforts, incident logs, performance metrics, and vendor behavior. We explored how to set early warning alarms using key risk indicators, utilizing the SAFE framework to guarantee sustainability, accuracy, fairness, and explainability. Finally, we discussed how algorithmic speed can be harnessed to organize and protect corporate data, provided the oversight tools themselves follow strict privacy rules. To make sure you are fully prepared to tackle these concepts on exam day, head over to RooCloud.com. All the vital topics, definitions, and frameworks from this session are covered in the multiple choice questions on the platform. Taking the time to solve these chapter-specific quizzes now will lock in your understanding before we move on to the next module. Keep up the great work, and I will see you in the next session.